Hello everyone, this is the chapter Relations and Functions. In this unit, we will learn about how to find the inverse of a linear function. Let f from R to R be given by the function f of x is equal to 4x plus 3. Show that the function f is invertible and find the inverse of f. Here, R is the set of all real numbers. And we will see how we can find the solution for this. Given f from R to R is defined as f of x is equal to 4x plus 3. As we can see that f of x is nothing but y, which lies in the range of the function. So if I say 4x plus 3 is equal to y, all x belongs to the domain R, set of all real numbers, and y belongs to the range R. Here both domain and range are set of all real numbers. So as we know that the function f, you can see here that it goes from domain to range, and the inverse function goes from in the reverse direction, that is from R to R. So let us see how we can proceed. So first of all, we should make the subject as x. So you know that y is equal to 4x plus 3 means to say that when you make x as a subject, you get y minus 3 by 4. So x is nothing but g of y. So it's a function of y. So let us define that function g from R to R. Here the range and domain of f has been interchanged in g. So this can happen only if the function f is both 1 and onto, that is bijective function. So let me define g r from R to R is as g of x is equal to x minus 3 by 4. Now f of x is 4x plus 3 and g of x is equal to x minus 3 by 4. For the sake of simplicity, we replace all the y's in g of y with x. Now let us find the composition of functions fog of x. So fog of x is f of g of x, which is nothing but f of x minus 3 by 4. You are substituting the function g of x inside the function f of x. So you get 4 times x minus 3 by 4 plus 3, and on simplification you get x. That means to say that f of g is an identity function. That means it takes x to x. Let me call this as equation number 1, and now we'll proceed further and find another composition of g of f of x, where g of f of x is equal to g of 4x plus 3, because f of x is 4x plus 3. Upon simplification you get x. That means to say that g of x is also an identity function. So remember that this identity function has the domain capital R. Since in this problem both domain and range are R, it doesn't matter much. But when in some other problem, when you have range and domain or different sets, one should be very careful. So let me call that as equation number 2. From 1 and 2 we conclude that both f of g and g of are identity functions. That means when they are identity functions, they form inverse of each other. That is, f of x is invertible, and f inverse of x exists with f inverse of x is equal to g of x is equal to x minus 3 by 4. But what does it mean graphically? Let me see this red line as 4x plus 3, the given function f of x, and the blue line, which is the inverse of f of x, that is g of x is equal to x minus 3 by 4, is nothing but the mirror image about the identity functions, that is y is equal to x. It's a mirror image of f of x. You can see that from the graph that if you plot f of x, one can obtain g of x just by taking the mirror image about y is equal to x.